I will hand it over to Dalway, who will walk you through the workshop for. Thanks, everyone.
Thank you, Nat. All right, so lab time. I will share my screen. So the lab material, you can find it here in this GitHub repository. I will share the link in the chat. Okay, let me briefly introduce this mini project. So we prepared a mini project. And as you can see in this diagram, there are two GitHub repositories and two GitHub actions. We use GitHub actions to build the CI/CD pipeline. So this part here is CI/CD pipeline for developers. So developers build their applications locally, and then when they finish it, they push the application to a GitHub repository. And then it triggers a CI/CD pipeline. So the CI/CD pipeline run a unit test and build the application and build a Docker image, and then push this Docker image to GitHub. So this process is automated. The second part is the infrastructure as code part. So this is a pipeline for the DevOps team. So we use IaC tools such as Terraform and Ansible. That way, we're able to use code to build all the infrastructure such as VPC, subnet, internet gateway, route table, security group, EC2 instance. So because they're written in code, that means we're able to make use of Git to do the version control. So we will write our configuration files locally, then push it to the GitHub. GitHub triggers, GitHub action is triggered, and it send the code to remote EC2 instance, which has Terraform and Ansible installed. Then it will run Terraform commands and Ansible commands to build 3 EC2 instance, or make sure that 3 EC2 instances are there. And Ansible will make sure that all the necessary packages are installed, and it pulls the latest image of the web application that our developer teams built, and run an instance of this web application on the 3 EC2 instance. That's a brief introduction. So let's go back. This mini project consists of 3 parts. So the first part is Terraform. We will introduce Terraform today, and the second workshop is about the Ansible, and the third workshop is about the GitHub action. So I hope after these 3 workshops, you guys have like a general idea how DevOps work, how the tools are used in this CI/CD pipeline. And you can find this README file, the lab material, in the main branch. And the code about the Terraform is in the feature Terraform branch. So if you switch it here and click on this folder, Terraform EC2 workshop, you are able to find all the configuration files, and also another README file. Okay. So, copy the HTTPS link here, and then open IDE. I use Visual Studio Code. So let me just open a new window. Clone Git repository, paste it here. Clone from URL, choose a place. I will just save it on the desktop. Okay, open it. Okay, so what is Terraform? Terraform is developed by a company called HashiCorp in order to manage infrastructures. It unifies the view of resources using infrastructure as code, support modern data center, expose a way for individuals and teams to safely and predictably change infrastructure, provide workflow that is technology agnostic, and manage anything with an API. Let's go to the feature Terraform branch. Yeah, so why do we use infrastructure as code tools? Because in the traditional IT infrastructure, they have to deploy their the latest version of their applications manually. It's a slow process, and it is full of human error. Also, to manage the hardware is expensive, and there are limited automation in the whole process. Terraform is a way to build infrastructure on the cloud. Also, you can use it to build resources locally. That works as well. Terraform can across platforms. Similar infrastructure provisioning tool, we have AWS CloudFormation. However, the CloudFormation only works for AWS. If you want to build resources on the other clouds such as Azure, Google, GCP, it won't work, but Terraform can do it for you. Terraform, the configuration files are written in HCL, HashiCorp configuration language. It's easy to install. Okay, so how to install Terraform? You can go to its official website, terraform.io/downloads. If you're using Mac, use brew to install. If you're using Windows, here's the download link. If you're using Linux, different operational system has a different way to install Terraform. Terraform. So how does Terraform work? Terraform uses providers, and providers are basically APIs of all kinds of resources, such as AWS, Azure, GCP, etc. Terraform make use of these providers to create or destroy resources on the clouds. Let's go to their website and take a look. So all the providers are stored in Terraform registry. Here are their feature providers. There are three kinds of providers. The first tier is called official providers. They're made and maintained by HashiCorp. And the second tier is called verified providers. They're owned and maintained by third-party companies. But those providers are tested, have been tested by HashiCorp, so that's why they're verified. The third tier is the community providers. They're made by individual contributors. Okay, let's use local provider. The provider name is called local. Let's use this one as an example. here, okay, we already clone the GitHub repository to our laptop. Let's open a terminal. Here we're at the main branch. As you can see, main here. Let's switch to the feature Terraform branch. Git switch feature Terraform. All right, here we're in the feature Terraform branch. And let's do a quick demo how Terraform works. So here's the local provider, and click this button, you're able to see the documentation of this provider. There are two, there's a resource and data sources. I will introduce them one by one. Here, the first one is a resource. So every object Terraform manages is called resource. And this resource type is local file. So what does it do? It generates a local file with the given contents. Very simple, it's easy to understand. We just copy this part, this snippet of code here. Let's create a new folder. I'll call it example. And now let's create a file. Example.tf. So Terraform is written in HashiCorp configuration language, and the extension of this file is tf. Hit enter. We have a new file and paste the code here. So let me explain this snippet of code. Let's make it bigger. Okay, so this part, resource, corresponds to the resource here. This is the block name. Okay, this block is called resource, and this part is called resource type. Let me create a comments on the top. So first part, block name and space. Second part is called resource type. Third part is called resource name. Okay. So this part is customizable. You can name it whatever you want. Let's give it another name. Let's call it hello, because I'm going to create a simple text file. The content should be hello with cloud data. And the file name, let's create this file on the in the same folder, in this example folder. And let's give this file a name. Let's call it hello.txt. So that's it. It will create a file called hello.txt, and the content of it is hello with cloud data. So after we create this configuration file, the next part is to initialize this folder. So the command we run is Terraform init. I should navigate to that directory at first. So cd example and run Terraform init. So here we only have one file under this directory, but when we run Terraform init, we will see a lot of things created by Terraform. Okay, so now we have a new directory. It's called .terraform. So what does Terraform init do? Let's go back to a README file. Terraform init. Okay, so it simply it initializes the project and it identifies what providers you used. So here the resource type is called local file. Obviously, the first part is the name of the provider. Here, the name of the provider is called local. The first part is always the name of the provider. So Terraform detects the local provider is used. So it download the providers, the plugin for the provider, and install it locally on your laptop so that you are able to use this provider to create a file. Okay. And the plugin is installed under this directory. Terraform providers registry.terraform.io, HashiCorp, that's the registry name, and local, that's the provider name. 2.2, that's the version number, I believe. All right, so we initialize this project. The next part is to plan it. Terraform plan. So it allows us to preview what resources is going to be created. So we hit enter. It tells us, okay, we're going to create Terraform is going to create a local file resource for you. The resource name is hello. The file name is hello.txt. Permission is 777. Directory permission 777. Content hello we cloud data, and it will generate an ID for you for this resource. So far the resource the text file hasn't been created yet. So the way we run this configuration file is to run this command terraform apply. So we hit enter. It will show you overview again, and enter value yes. Okay, so now a new text file is created, hello.txt, and the content is we cloud data. At the same time, a Terraform state file is created. So the state file is a JSON file. It contains all the information of the resources. So this file is actually very sensitive. You shouldn't when you commit your code, you shouldn't upload this file, push this file to your GitHub, all right, because it has all the sensitive information. This is a file, a local file, but what if you create a EC2 instance? Then other people will see, okay, the security group information, like IP address of the EC2 instance. So it's really dangerous. So I highly recommend you guys to add this file to your git ignore file. So this is the state file. When you run, after you run Terraform apply, this file is created. All right. So if we change, update the content in this file manually, hello we cloud data, hello everyone. Terraform is able to detect the drift and destroy the old file and create a new one with the same content. Hello we cloud data. Let's just try it. Terraform apply. Now every time we run Terraform apply, we have to enter a yes here. The one way to avoid that is to add a argument, a flag, auto approve, so that we don't have to enter yes every time. Okay, so looks like the content is update. It's update back to the original content. Hello, we cloud data. So Terraform has the ability to make sure that the resource is in the state as you define. Okay, so this is a resource type, local file. Each resource type has many arguments. Each resource type has its own argument. The local file has file name, content, sensitive content base 64, source, file permission, directory permission. Here from the state file, we can see the file permission is 0777. Let's add a new argument and assign a new file permission. So file permission equals, I'll give it 700. And now let's run it again. Terraform apply. So from the terminal, as you can see, this part is changed, false replacement. So this file will be destroyed and recreated. One file destroyed, one added. And now, when you see the permission, ls, or this here, it has read, write, and execute permission. So it's basically 700 hello text. All right, this is the resource block. Provider has another resource, which is called data sources. So resource allows you to create a resource somewhere on your local machine or on clouds. But data allows you to read the resource that is not created by data not created by Terraform. So for example, let me create another text file. I call it name.text. So I create this file manually. Terraform is not able to manage the resource that are created by other applications, but it can use the data block to read the content of the other existing resources. I will hit enter my name here, that way. Okay, so we create a text file name. Content is that way. Let's use the data block to read the content of the file. So I copy this part here. So this time the block name is data. The resource type is still local file, and we can give it a new resource name. I will call it name. The file name, here we enter the path of the file /name.text. So this will read the content of this file, and we're going to reference the content of the file here in the hello text. So how to do that? The content is here. We use interpolation sequence, $, and curly braces. And how do we reference it? You start with data, and then the resource type dot local file dot the resource name. In this case, it's name, and the attribute. So the attribute, you can find it in the documentation. The attribute we can use is content or content base 64. Here, in this case, we use content dot content And let's run it again. Terraform apply. By the way, before we run it, as you can see, there's a Terraform state file and a Terraform state backup file. This file keeps a record of the current state of the resources, and this file keeps the previous state of the resources. And if we run this command, both state files will be updated. Terraform apply and the value yes. So the content of the hello.txt is what was modified. So here, instead of hello, we call that it becomes hello that way. That's how we use the data block. Okay, so now we want to we create one text file, but what if we want to create 3 identical text file and give them different names? We can use a meta argument. So the meta argument is not defined in this document. It's a meta argument, which means it works on most resources. So here we define a variable, and give this variable a name. File name, variable file name, and we can define the type of the. Here we declare the variable. We can define the type of the variable using type argument. Define. I will make it a set of string. Set of string, and the value. The default value is hello 1. Okay, hello 2. Let's create 3 files. Hello 3. And here we use a meta argument called for each. Then we reference the variable here. Var. We use var dot and the resource name is, in this case, is file name. And we need to update the file name here. So this time it shouldn't be hello.txt. We need to reference the for each meta argument. Use a $, curly braces, each dot value dot text. Let me double check if I did it correctly. It should work. So with this meta argument, we're able to create three text files named hello 1, hello 2, hello 3. Terraform plan. Okay, 3 files to add. Terraform apply, auto approve. Here we create 3 files, and all the content of them is hello that way. So this is just a very simple example to show you how blocks are used, and how do we create resources, and how do we name the resources. Okay, now you should have a basic understanding of Terraform. There are other blocks. We introduced variable, data, resource, and output. So output allows you to print the attributes of a resource every time you run Terraform apply. So it will print attribute of resource here in your prompt. We will see that in the next example. All right, this part is done. Okay, let's destroy all the resource that I created. Terraform destroy. This will create delete everything, every resources. Auto proof, of course. So all the hello.txt are gone. And here, let's take a look at the state file. All the resources are gone. However, the state is recorded here. The state of the previous, the previous state of the resources is created, is stored here. All right. I'll just delete this folder. Here, let's take a look at another example. So this lab, we're going to use Terraform to create a VPC and create 3 EC2 instances in this VPC. By VPC, I mean all the components inside the VPC. So the components include a VPC, internet gateway, one subnet, one router, and a resource to associate with the router and the internet gateway. Also, to create a VPC, you need to have the image ID and a security group. Here's the configuration file. It's relatively more complex than the previous one. So we have, this time we use AWS provider. The documentation of AWS provider can be found here in the registry, Terraform registry providers, AWS. This is the first one, documentation. On the left side, you can see a list of resource types that you can use. Here we define the provider we're going to use, AWS, and I define the location of my AWS credential file and the profile name of the config file, the region where the resources should be created at. Here I define many variables. I declare setter blocks, subnet setter blocks, avail zones. However, I left this part empty, so the type and the default value are not it's not defined. I define them in a separate file called terraform.tf files. So I define all the values here. Later, when I run Terraform apply, the values in this file will be assigned to the variables here. All right. Use the AWS VPC to create a VPC. Use AWS subnet to create one subnet. Use AWS route table to create a route table. The route and tags are the arguments inside this resource type. Create another internet gateway, create a route table association, create a security group. Inside the security group, we have ingress and egress. So they're basically inbound rules and outbound rules. This part opens the port 22. Port 22 is for SSH. Port 8080 is for web application. Port 80 for web application as well. Egress from port 0 to port 0, that set of blocks is 0.0.0.0. That means everywhere. So it allows the EC2 instance to, to visit the internet. Every IP address in the internet. Here is a data block. So it reads the image ID from AWS, and here is the output. So after we run this configuration file, the AWS AMI ID will be printed in the prompt. And here we'll create a AWS keep here, because when you launch a EC2 instance, it forces you to have a keep here so that you are able to connect to the EC2 instance. And the last part, this is second last part. This part is AWS instance. So here I used for each meta argument. I showed you how it works before. So this will allow us to create as much number of EC2 instance as the length of this variable instance name. So it will create 3 instance, and they're called instance server 1, server 2, and server 3. All right, and finally, we'll create a local file and print and save the IP address of the EC2 instance in that local file. Let's navigate to the directory cd upper level Terraform. Oh, I moved it to trash. It's okay. Let me just open a new terminal. cd Terraform. Cool. Now we're in this folder. ls. So when the EC2 instance is created, it will pass this script to the EC2 instance and run this script. What this script does is that it updates the packages in the EC2, start the Docker, and add EC2 user to the Docker group, and then run Nginx instance. Okay. Let's just run this configuration file. Terraform, apply, auto approve. So after running this command, all these resources will be created. And also a new state file will be created. Oh, before I run this command, I have to, initialize this project. Terraform init, very common mistake. So this will detect providers used in this configuration file, and download it and download them and save them, so that you're able to use them. Okay, this is a list of providers. If you want to see the list of providers, there's another way: Terraform providers. Okay, we have 2 providers, AWS and local. Terraform plan. Let's preview the resources that will be created. Why is it so slow? Okay, cool. So this is a preview. Let me log into my GitHub account. I mean the AWS account. AWS. Sign into my console. Sign in. Multi-factor authentication. All right. So now I'm using the AWS portal. As you can see, there are 3 VPCs and EC2, Virginia. Okay. There's no running EC2 instance right now. Okay, let me run this configuration file, Terraform, apply, auto approve. And now Terraform is creating all those resources in the configuration file for me. Let's see, refresh. Okay, here we have 4 VPCs. Devops Bootcamp VPC has been created. Now let's go to the EC2 instance. We have Devops Bootcamp server 1, 2, 3. 1 and 3 are running. 2 is okay. 2 is also running. All right, and here we have outputs. Do you remember that we defined our output here? One EC2 public IPs. This is one of the output. That's the last one. And another output is called AWS AMI IDs. It's here. Output, that's what output does. It prints the value, the attribute of a resource on your prompt. Also, resource local file saves the IP address of the EC2 instance locally. Saved here. Okay. Devops Bootcamp instance public IPs .text. The IP is 9.93.176. 3.93.176 look there exactly the same. And also the Docker instance should be running inside this EC2 instance. We're able to reach it through the public IP port 8080 because I map it to port 8080. Okay, welcome to NGX. It worked. Let's take a look at the other EC2 instances. Server 2, copy the IP, should give me the same page, port number 8080. Okay, welcome to NGX. If you guys want, you can reach it on your own. Sorry, I ignore the chat. Okay, just send one IP to the chat. You guys can try it out yourself. Don't forget to add port number 8080 at the end. That's basically it. Some of you might think here we define the ingress rules. This is not elegant way to define the ingress because we did the same thing like 3 times. Here's another way we can use. We can comment out this pattern and use dynamic argument. So here we use for each again and define the port number in a variable and pass the value to this block. So here we update the code, but the result is actually the same. So if we run Terraform plan, it will show you that nothing will be updated. Terraform plan. No change. Okay. That's basically it. All right, let me clean up all the resources. Terraform, destroy auto-proof. This will destroy all the instances and VPC, subnets, everything. Let me take a look at the lab material. Did I miss anything? Terraform show, format, validate. All right, seems like I destroy all the resources too early. It's okay because we have the configuration files. We can install, launch all the resources again very easily. All the EC2 instances are terminated. VPC. Okay, the VPC is gone. Destroy complete. Everything is gone. Let's just apply it again. Okay, the VPC is back. And EC2 instances are pending. Yeah, let me show you some interesting commands. Terraform FMT, Terraform format. This will link your code, make your code look nice. Terraform format. Nothing changed. Why? Because I ran it before, so it's already nice. Terraform validate. This checks grammar mistakes, syntax mistakes in your Terraform configuration files. Terraform plan out, you can save your plan in a file. Terraform apply input plan file. You can use your plan file as input to create infrastructure. Terraform destroy allows you to destroy the resources. You can also specify a target so that it only destroy one resource. Terraform state list. This show you the list of resources and components from the current state. Terraform list. No, Terraform show. Okay, so it basically prints everything in the Terraform state file. Terraform state list. It's not Terraform show. Terraform state list. here's the list of resources that we created. This is data. That's not what we created. That's what we get from AWS. This is a resource. Server 1, server 2, server 3, an internet gateway. We also create a AWS key pair, route table, a subnet, a route table association, security group. A security group, a subnet, VPC, and a local file. What else? Terraform state show resource name. Okay, we can also show all the attributes of one single resource. Let's choose this one. Terraform state show resource name. Okay, it shows all the attributes like CIDR blocks, network ACL ID, route table ID, everything about this resource, this VPC resource. Also, there's another tool, another Terraform tool. Very interesting one is Terraform console. So when you run Terraform console, it reads everything in your state file so that you are able to query all the attributes of your resources, and it supports math operators, logical operators such as 1 + 1 equals 2, 2 8/2 4. And true and false equals false. True or false equals true. And some useful functions like floor, (8.2 = 8), max 6, 4, 2. That's not the way to use max. Like that. Okay. Equals 6. So many useful functions you can use, and we're able to query the resource. Here, AWS VPC, it prints all the attributes for you. If we want to see the CIDR block, so append it at the end. CIDR block. Okay, that's the correct way. Use dot. What else can I talk about? Nope, that's all. That's all for the lab. Thanks guys for joining this lab. I'm also very glad to be here. Yeah, we will provide a recording of this session. I think we will post it on YouTube. And this is just the first part of this project. Because this project has 3 parts. Finally, we're going to have two pipelines, create a project like this. When the record will be posted on YouTube, I don't know. It depends on the operation staff in our team. Not sure, but definitely we will post it. Okay, 1 to 2 weeks from now. All right, so that's it. You guys can download clone the Git repository and install Terraform and try it out on your laptop. Thanks again for joining this session, and guys, I will see you in the next workshop. All right. Thank you, everyone. Bye.
Recording.